49 minus 1.5, and then you have gotten 0.7 49 amps is the one that is passing at I2. Okay, so that's how you can get the circuit analysis. Okay, because once you add back that current total equals to I1 plus I2. So I2 equals to 0.749. Then I1 equals to 1.5 amps. Okay, so if I want to know that this is correct, just a matter of saying IT, the total, equals to I1 plus I2. Then the I1 is 1.5 plus the I2 is 0.749. And then this will give me 2.249 amps. Okay, as the total current that is passing through this parallel circuit. I hope you have understood one or two, three things. And the other emphasis that I would like to make is that when you are doing this, before you start answering questions, providing solution to the questions on circuits, either in series or parallel, you have to make sure that you identify, is the circuit in a parallel or is the circuit in series, so that you can know the correct formulas that can be applied in such cases or scenarios. Okay, so ladies and gentlemen, this is a Radical Academy, and we teach you interactively. If you have not understood, you can also comment in the section, in the comment section below, so that we can also help you so much that we can also even repeat out this course that we have just watched. Okay, so I believe and hope that this is something that is going to blow up your mind and change your mind, because we make it as simple as easy so that you don't get confused. Okay, so this is the end of our session under calculation of our resistance, how you can also prove the other quantities, like how can you find the total current, how can you find the total voltages in the two types of circuits, like the series as well as the parallel. Okay, so it's bye-bye, and my name is Mike Wara. I am the founder of Radical Academy, and I'll see you in the next video.